In this video, we're going to talk about functions and their graphs. First, we're going to talk quite a bit about functions. So the definition of a function is a rule that assigns each input to exactly one output. So you know exactly what you're going to get. If you put in a value, you get the same value back each time. The domain is the set of all inputs. Usually you can think of it as all of the possible x values. And then range is the set of all outputs. Now, which is all the possible y values. So this is a pretty simple definition for a very complex concept. So we'll talk about domain and range really probably throughout your math class, but definitely today. But before we do, let's talk about an example of determining if things are functions or not. So if a relation is a function, that means every input has exactly one output. Or another way of looking for that is the x values cannot repeat. So this is a function because every time I put in 5, I get 3. There's no other option. Every time 9, 17, 14, -4, 19, 5. So this is a function. The x values do not repeat. Here, if you look at this function, or this relation, I say function, but it might not be one. This is not a function because sometimes when I put in 5, I get 3, and sometimes when I plug in 5, I get -1. So this is not a function. You might also remember thinking about the vertical line test. So the vertical line test, if you look at the graph of a function, let's look at 2 of these, or a graph of a relationship. If I had something that looked like this versus something that looked like this, this is a function here because I can draw a vertical line everywhere on the graph and it only touches in one spot. But this is not a function because if I draw this vertical line, it'll touch in 2 different spots. So this is not a function. And that indicates that the input, whatever number this is, has 2 different outputs. It's going 2 directions, so you're not sure which one it is, so it's not a function. Function notation is something that is somewhat confusing at times because it's very easily confused with multiplication. But if we have something that looks like this, a lot of times you use F or G or H are pretty common letters for functions, but you can use any letter. There's nothing that says you can't. But the way you say this is F of X, and it is not multiplication. Which is very confusing because it looks like multiplication, right? Like it looks like it's F times X. That's we use parentheses for multiplication, but it's not true. That whatever number is here or value is here is what the function is in terms of, or you can think it's what is being plugged into the function. It's the input. So one thing we can do with functions is just translate from words to an expression. To evaluate F of X, so that's our function, divide the input by 3 and add 2/3 to the result. So we're going to use X for the input, divide it by 3, and then add 2/3. And let's look at another one of those. So go ahead and pause the video and try this one on your own. So to evaluate g of x, so that's our function, subtract 4 from the input and multiply the result by 3/4. So order is important here. We're going to subtract 4 from the input, so it's x minus 4. And we're going to multiply that by 3/4. So we'll put parentheses around it, and typically the 3/4 would go in front. Okay, on example 5 with a and b, it says evaluate the functions at the indicated values. And so this means to plug 1 over x in for t. So everywhere you see a t, h of 1 over x, we're going to write a 1 over x. That'd be 1 over x plus 1 over 1 over x. Okay, and so technically, like, you've done it, right? You could say, well, I plugged it in, but we always like to simplify it. We're dividing by a fraction, so you multiply by the reciprocal. So h of 1 over x is equal to 1 over x, and then plus it's just x, to simplify that. If we plug in 0, and pause and try to do that if you haven't already, you plug in 0, you get h of 0. So this means you plugged in 0. It does not need to multiply by 0. Is 0 plus 1 over 0. So this is a problem, right? You can't divide by 0. It's not allowed. It makes no sense in math. So we say this is undefined. Do not say no solution. No solution and undefined cannot be used interchangeably, but it is undefined. Okay, and try a few more of these. Go ahead and pause the video and try those. I mean, you can use a calculator on this if you want. That's fine. We'll see if I need one or not. Make sure when you square the negative, it becomes positive. But this just means to plug in -2 for x everywhere. And so this becomes, and you're not going to, there's no like operation to do over here. This is just telling us what we did. It's you don't have to divide by -2 or anything to get by itself. This would be 4 plus 6 plus 1, if I can do my mental math correctly, and you get 11. So when you plug in -2, you get 11. So input -2, output 11, and really try to think of it as input and output relationship. Okay, this one is a little bit more work. We're plugging in x minus 1. So everywhere you see an x, you're going to write x minus 1. Well, what would that look like? That would look like, instead of x minus 1 squared minus 3 times x minus 1 plus 1. And then we're going to go ahead and simplify this. Remember, you cannot distribute that exponent to those two. It's subtraction. That's what we call the freshman dream. We want to square the binomial. Let's go ahead and distribute the -3x, -3x, positive 3, and then plus 1. And then we'll FOIL this. We'll do this in one step. So we'll combine the outside terms so we get an inside terms. X squared, and then minus x and minus x give you -2x plus 1. And let's go ahead and combine the 3 and 1 to get 4. And then finally, combine like terms, you get -5x's. And then 1 and 4, I forgot to write my plus 4, make 5. So f of x minus 1 is equal to all of this. And if you haven't already, try C. Once again, you're plugging in b of 5 for x. So it's b to the 5th, or b to the 5th for x, squared minus 3 times b to the 5th plus 1. And so not much you can do there other than simplify this. Up high you multiply. So this is b to the 10th minus 3b to the 5th plus 1. Okay, so domain. There's a lot of things you can talk about with domain, but there's two really common places you can spot domain algebraically. And so that's with fractions and even radicals. And let's see, let's put this down a little bit. So with fractions, your rule is to set the bottom not equal to 0 and then solve. With even radicals, the rule is set under radical greater than or equal to 0 and then solve. And so let's talk about why. Why this is because I cannot, with fractions, I cannot divide by 0. And so if I knew where the bottom was equal to 0, then those were all the values that x can't be. So x can be anything except that. With radicals, even radicals, like a square root or a fourth root, with the square root, I can't take the square root of a negative number and get something real. It turns into a complex number, imaginary number. But so for our purposes, we cannot take a square root of a negative number And so that's why we figure out where it's positive. Setting it greater than or equal to 0 is going to say where is the radical positive, and then solve. Work to memorize these. Domain is just so tough. It's so difficult to understand. And even I would pause this and try to think about these two rules to try to understand them. But even still, it's going to take a little while to really understand it. But you can at least just memorize it. So then it's like, well, I see number 8 here. It says find the domain of this function. Well, do I see a fraction or do I see a radical? Yes, I see a fraction. What's my fraction rule? My fraction rule is to take the bottom, or the denominator, and set it not equal to 0. And then just solve it like you normally do with the equal sign, right? So add 6 to both sides and then divide by 3. So that means x can't equal 2. And we want to use some good notation. There's 2 different ways to write this. One is with set notation. And so you just add the x in the bar for such that and those brackets. And that's pretty good. You could do more than that, but we'll kind of cut it off there. Or you can do interval. So this is called set. In interval notation, you talk about everything it is. So it's everything from negative infinity all the way up to 2. And then we're going to skip 2 and go to infinity. So to skip a number, you use a parenthesis, this union sign, and then the number again, and just continue on. It's important that you have parentheses and not brackets here. And either one of these is fine for the notation. So here you think, okay, I got to find domain. I have a radical. So my rule is I set the radical greater than or equal to 0 and then solve. So negative 3x is greater than or equal to negative 7. Divide by negative, that switches the sign of the inequality. And then it also, well, you just divide, makes this 7 over 3. And so we can write this as set notation with our brackets, or we could do interval notation, which is everything less than 7/3. So that's from negative infinity all the way up to 7/3. And it's a bracket because it can be less than or equal to 7/3. Okay, number 10. Number 10 is a little confusing because there's 2 parts, right? There's a fraction and a radical. So one thing I want to say is I don't care about the top of the fraction at all. It doesn't matter that there's an x on top. What matters is there's a radical there. So because of the radical, I can set x is greater than or equal to 0. Okay, that's part of it. And then the bottom has to be, I can set that equal to 0. So let's see if we can factor this guy. I need 2 numbers that multiply to negative 2 and add to 1. And sure enough, those are 2 and negative 1. So then I can rewrite minus x minus 1. And if I take out a 2x, I'm left with x plus 1, and then a minus 1 and x plus 1. And so then we can continue to factor. And then to solve this, we're going to set both of these equal to 0. So you get x equals negative 1, and then x is equal to 1/2. Okay, so that's part of our domain is those can't be. So x can't be negative 1, and x can't be positive 1/2. So let's look at what we have. We've already said x has to be greater than 0. So we think about a number line maybe. Here's 0. Well, x has to be greater than 0. X can't be negative 1, so negative 1's bad. But I've already eliminated negative 1, so we can just kind of ignore that. And then x can't be 1/2. So if 1/2 is here, 1/2 is bad. Okay, so then how are we going to write this? Okay, since we have a number line, interval notation is kind of nice here because we can just take away the line. So we have 0. And then at 1/2, I'm going to have a break. So remember, you use a union sign to skip a number, and then it goes to infinity. So this is a pretty good way to write it. Or you can use a combination of these guys and write it as set notation or set builder notation. And x has to be greater than or equal to 0, and then just use a comma, but x can't be 1/2. Once again, either of those is fine. So domain of functions, pretty tough. But remember these two things. If you can keep these two rules memorized, you're in pretty good shape. If you don't have those rules memorized, you're just probably going to miss the question at this point in your math career. When you get a little further along with the graphs, which we'll talk about, you might be able to figure it out from the graphs instead of looking at it algebraically. But really try to memorize these two rules for domain. Okay, and then the last thing we'll mention is just these parent functions. And there's not really too much to write or see, just to review these and make sure you know what they look like, their expected shape. So this is just a line, and we'll kind of rewrite these in under here. So just y equals x. Y equals x squared. If 2 is the biggest exponent, you expect it to look like a parabola, or U, where it's opening up or opening down. And then y equals x cubed is a cubic function, and these will take this shape here. Absolute value, let's see, probably should say absolute value there. Absolute value of x, those look like a V. They have a vertex here. Same thing here. This has a vertex. We call this point here an inflection point. And we'll move these graphs around. This is the reciprocal function or a rational function. And you can see we talked about the domain of a fraction being where the bottom is equal to 0 or not equal to 0. And x can't be 0, and so you can see how this graph breaks where x is 0. Same thing with the square root. Square root has to be positive. You can see where the graph is only where x is positive. It's not where x is negative, or similar thing. And then the exponential graph and log graphs, we'll talk about those probably or later, not in this video really, but you can kind of see their shapes there as well. Okay, good luck with graphing functions. If you have any questions, please reach out.